thermal energy, temperature, and heat. Okay, this question asks for the amount of heat. So Q is our question. We know delta T is going to be 6 degrees Celsius. We know C is 4.18. And we know the mass is 8.4 kilogram. And that's joule per kilogram degrees Celsius. So now we just put in our equation. Q equals mc delta T. We get 8.4 times 4.18. Sorry, this was times 10 to the 3. Times 10 to the 3 times 6. And we get 2106.72 joules. And that gives us a final answer of 2.1 times 10 to the 5 joules. Now again, this question is asking for Q, and it's saying determine the heat lost when a piece of 540 gram piece of silver cools from 78 to 14. First of all, let me make one correction. That should obviously be 10 to the power 2, not times 102. So anyways, Q is our question. Now heat loss, that could come out as a negative number, but we could just find Q, and since we know heat is being lost as the temperature cools, heat is lost to the environment, we can just find the Q value, and we know that that is the heat lost. So Q is our question. M is 540 grams, which is equal to 0.54 kilograms. We know delta T is 78 minus 14, which is 64 degrees Celsius. And we know C, because it's given, of 2.4 times 10 to the 2. We put into our equation, Q equals mc delta T, 0.54, 2.4 times 10 to the 2 times 64. And as an answer we get 8294.4, which equals 8.3 times 10 to the 3 joules. That's the amount of heat that is lost. Okay, this one is asking for the specific heat capacity. So we are looking for C in this question. We know M is 5.0 kilograms. We know Q is 0.50 megajoules, and we need to convert that to joules. So we're going to move that over 1, 2, 3, 4, 5, 6. Put our zeros in there, and that's going to work out to be 5,0,0,0,0. Sorry, too many zeros. Sorry, not too many zeros. The question is wrong. Sorry. Let's do that part over again. Q is equal to, as it says right here, 0.050 megajoules. Now when we move it over, 1, 2, 3, 4, 5, 6, 0, 0, 0, we get a Q value of 50,000 joules. And lastly, we have our delta T, which is 42 minus 32, which is 10 degrees Celsius. Now we're ready to put into our equation. Q equals mc delta T, 50,000 equals 5 C times 10. C is going to equal to, when you do your rearranging, 1.0 times 10 to the 3. And that's joules per kilogram degrees Celsius. Hey, one note please, again this should obviously be 10 to the power 2, not 102. So determine how much brass can be heated. So we're looking for mass. That's our question. Q, we are told, is 1.0 megajoules. When you do this, 1, 2, 3, 4, 5, 6, put our zeros in, we get 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. So 1,000,000 joules. We also know C, 3.8 times 10 to the 2, and we know delta T, 32 minus 20, which equals 12 degrees Celsius. Put it into our trusty equation. Q equals mc delta T, 1,000,000, m 3.8 times 10 to the 2 times 12. You do your rearranging and you get a mass of 219.3 kilograms. We need 2 sig digs, so 220 kilograms. Okay, obviously that should be times 10 to the power 2. So in this case we're looking for the new temperature of the glass. So what is that? Well, we obviously need TF. So our delta T, which is equal to TF minus TI. TF is our question. TI initially at 41 degrees Celsius. Okay, what else do we know? We know Q. Now it loses this heat. So we're going to get a negative number for our Q. So our Q is going to be negative 4.2 times 10 to the 4 joules. Okay, it loses heat, so the system has a negative Q value. We know mass is 2.5 kilograms, and we've already established T. So our equation, Q equals mc delta T. Q we know is negative 4.2 times 10 to the 4 equals mass we know is 2.5. C we are told 8.4 times 10 to the 2. And our delta T is going to be TF minus 41. Now a little bit more math involved, left side of the equation. Do a little division and you're going to get negative 20 equals TF minus 41. You rearrange and you get a TF value of 21 degrees Celsius. Okay, now in this question we're looking for the final temperature of the iron and of the water. Okay, we're given the C's for each. And note, final temperature for water and iron will equal because energy will keep going back and forth until all the particles have the same average kinetic energy. If you remember, average kinetic energy means temperature. Okay, so let's take a look. Let's break this up into iron. Oops. Iron and water. Okay. Let's use red for water. Keep things straight. Okay. So on the left, iron. We know the mass, 200 grams, so that's 0.2 kilograms. We know the TI is 350 degrees Celsius, and we know C, because we're told it, is 4.5 times 10 to the 2. Okay. Water, likewise, we know mass, 300 grams, so 0.3 kilograms, and the Ti is 10 degrees Celsius, and the C for water is 4.18 times 10 to the 3. It's important to break it up like this so you make sure that you keep your terms straight. Now, how do we do an equation like this? Well, we know that whatever is lost, the energy that's lost, is going to be gained. So iron is going to lose energy. It has a higher temperature. Some of that heat is going to move from the iron to the water. So that's why we put a negative in front of the iron, and that's why we put it lost. Now on the left side we have M, because Q equals MC delta T. On the right side we have MC delta T. On the left side, remember that's negative, so let's put a negative out here. We'll put some square brackets. And we'll put the mass. We know the mass is 0.2. We know the C is 4.5 times 10 to the 2. And we know delta T is TF minus 350. On the right side of the equation, we have 0.3 times 4.18 times 10 to the 3 times TF minus 10. Left side of the equation becomes negative 90 times TF minus 350. Right side is 1254 times TF minus 10. You do your rearranging. You're going to multiply this 90 through. Okay, you're going to end up getting negative 90 TF plus 31500 equaling 1254 TF minus 12540. And that's just me multiplying through. Okay, I'm going to take the 90, multiply it there, the 90, multiply it there, the 1254 there, and there. Okay. Now we need to collect like terms, so let's bring this, we'll have to bring this over here. Okay, so let's collect some like terms. We're going to end up getting 44040 equals 1344 TF. You divide both sides and we get a TF value for both of 33 degrees Celsius.